afternoon, I told Dave that it really speaks to his magnetism. We have a full house on a beautiful sunny afternoon, so thank you all so much for being here. I think probably a lot of you know this guy, but we're really excited to have him here in this forum to share an interesting perspective. So he and I were chatting this winter, and he was mentioning that he had a lecture to the American Physiological Society with a similar title, and it sort of piqued my interest because I thought, you know, the search for truth is something that is an interest to all of us, and I think especially in science, because we really relate scientists to trying to help us understand the world around us, right? So looking for truth in these natural laws that govern much of the phenomenon that we experience. But the question that Davis has posed to us is whether or not there are similar laws that regulate more human disciplines like economics. And so I think he's going to share some interesting info with us about the connections or the similarities between science and economics. So we're very excited to have you with us this afternoon. For those of you that don't know, Dave is a retired physiologist. He was the director of the MDI Biological Laboratory and is a musician. You may see him around town playing various venues. So join me in welcoming Dave Dawson.
Thanks, Jerry, and thanks to you all for coming. I'm very grateful for the opportunity to present this. Economics is a new undertaking for me. I just started studying it about a week ago. Actually, when I retired about 5 years ago, because it's been a long interest of mine as a scientist. And so I hope you will enjoy this. And it's my intention to be somewhat provocative, so we'll see what happens. This is my alternate title. Why is it so much easier to lie about economics than physics? That will give you a sort of a hint of where we're going. So what motivated this? I've been thinking a lot, particularly over the last 2 years, about truth, as some of you may have. And so I started asking myself, why is truth important? Well, truth, I think, one metaphor we might use is, truth is our GPS. It tells us how to navigate in the real world. And this is something that I think science aims to do. Science aims to create an accurate map of the real world, and in particular to understand causality. Why do things happen? I mean, in medicine, why do people get diseases? Why do certain treatments cure them? Okay, so that's sort of the perspective. This is a wonderful little book, by the way, if you get a chance to pick it up. It's Truth Decay. And the perspective that I like is really represented very well by this quote from Hannah Arendt, who many of you may know was famous for her studies of the Nazis and for her comment about the banality of evil. And she said, the result of consistent substitution of lies for truth is not so much that the lies will be accepted as truth, but that the sense by which we take our bearings in the real world is being destroyed. In other words, our navigation, our GPS, is being muddled by this. So where does truth come from? So that depends on who we trust, because we get truth, we get our news, we get our facts from various sources. So this is a little survey that was done in the UK a few years ago, and most of you can find yourself on this scale somewhere. You see, who do we trust? Net trust. So nurses do very well, by the way. Physicians, and historians do well, scientists, but you see, scientists do well, economists not so good. And they're not the worst, however. The worst, of course, are politicians. You can tell this is from Britain. They talk about your local member of parliament. So what are we going to talk about? We're going to talk about the origin of scientific truth. So I'm going to give you a very brief course in physics. Okay, so for some of you that may be painful, you can just hold your breath for a few minutes. to talk about the importance of scientific truth to our sense of causality. In other words, why things happen. I also want to see if there are links between the evolution of scientific truth and the people who uncovered it and the history of economics. And some of these things I think will surprise you. And I want to ask, are there principles or truths that enable us to impute causality in economics? Now I want to say, before I begin, in case I forget to say it at the end, where it might be more important or more appropriate, that I will say some things that might be termed as being critical of economics. However, having studied economics intensively now for all of 5 years, I must say that I can think of nothing that's more important. Because it touches everything we do. And it's immensely complicated, much more complicated than the biophysics that I used to do. The stuff I used to do was a day at the beach compared to this. So, why does a scientist get interested in economics? As I just said, these theories have a profound impact on how we manage our lives, but they often seem impossible to understand. Economics is an academic discipline, often referred to as a science, but it's not immediately obvious whether there are principles that can be relied upon to impute causality. Virtually 100% of what politicians say about economics is not economic science, but rather economic ideology. I'm being kind, and most of it is just bullshit. I'm going to say it's ideology to dress it up a little. So my goal was to find out whether there was any science in economics, and to ask this question, to which I will return later in the talk. What do economists really know? Now, there are at least two in the audience. Okay. So if two people get up and leave in the middle, you'll know who they are. So we'll see what happens. So where does scientific truth come from? Well, observation. You measure a few things. Quantification. You determine the relationships between things, between one thing and another. And then you generalize. You predict other things from those relationships. That is one way of looking at natural science. So let's choose an example. So now we're starting our course in physics. This is Galileo, who some of you may have encountered. This guy was amazing. He was doing experiments, I think, in his sleep. He did so many. And often called the father of experimental science and even the father of physics. And he studied the motion of falling bodies. This is an actual picture of him here, dropping weights from the Eiffel Tower, yeah, the Leaning Tower of Pisa, probably an apocryphal story, but he found that this rate of fall was independent of mass. Okay, interesting observation. Then came Kepler, about the same time actually, studied planetary motion and developed an empirical description of it. And he said this famous quote, "There is a force in the earth which causes the moon to move." Now that doesn't sound very profound to us now, but imagine what it meant then. But then, this burst of light occurs on the scientific horizon, and that's Isaac Newton. And his major work, known to those of us who love it as the Principia, his study of the mechanics, the study of gravitation, and just as an incidental tag along, he invented calculus. Okay, so not bad. So let's look at what happened. So we start with one of, I think this is his second law of motion. It says that if we accelerate a body by applying a force, that acceleration, in other words, the rate of increase of velocity, is proportional to the force we apply, but it's inversely proportional to the mass. The heavier something is, the harder it is to move. Okay? So this also gives us a sense of causality. It accords with what we know. We push something to move. So the acceleration is the force divided by the mass. Then he comes up with the law of universal gravitation. Again, this is from observing planets, you know. And this is in the 1600s, amazing. So he says there is a force, a gravitational force, and I reckon that that is proportional to the product of the masses of the two bodies, okay, the masses of the two bodies, divided by the distance between them squared. So it's one example of an inverse square law, of which there are many in physics. So what happens when we say, let's substitute gravitational force in this equation? This is starting to feel painful, but it's going to be over soon. We're going to substitute gravitational force in that equation, and what happens? We get this. The acceleration is equal to this term with the masses over r squared divided by the mass of the falling body. So what happens? Cancels out. So we get Galileo's result. So this is an example of how science, particularly physics, is supposed to work. You find principles, you apply the principles, and you apply them to other things. And this is just, I want to show you this. This is just an experimental version of what you just saw, if I can get it right here. This is Apollo 15. So why did that work? Well, of course, on the moon, there's practically no atmosphere. So there's nothing to impede the feather. Right? And the mass of the moon is a lot less than the Earth, so everything fell in slow motion, as you can tell. So it's impossible. This is one of the things that has been interesting from studying not only economic history, but also just history of science that went along with it. It's impossible to overestimate the influence of Newton. I mean, this guy changed everything because he changed the way people think about doing science, and not only natural science, but social science as well. So he showed that you could discern natural laws that had causal implications. You could understand how the world worked. They could be expressed mathematically, in this case to predict the behavior of falling bodies. And in this case, a very expensive experiment was done, which seemed to verify those predictions. And economic and other social science thinkers for centuries would try to emulate Newton's method and his mathematics, calculus. We'll come to more of that later. So, where does our sense of causality come from, our sense of reality? Newton's laws of mechanics and gravitation, thermodynamics, Le Chatelier's principle in chemistry, Maxwell's laws, Ohm's law. I mean, there are dozens of these things we could tick off that bring back painful memories of your physics courses. So there are dozens of them. And all of us who are doing science, as Newton articulated, are standing on the shoulders of giants. So what we do today rests on this foundation that's been building over centuries. So who are those giants? Let's take a look at them. So some big shoulders: Aristotle, Copernicus, Galileo, Kepler, Newton, Bernoulli, Faraday, Coulomb, Joule, Maxwell, Boltzmann, Planck, and Gibbs. These are just a few. So these are a few of the people who have contributed to these principles. So why do we have less confidence in economics? So two hypotheses. One is that the giants of science that we've just mentioned, and upon whose shoulders we all stand if we're doing science, had no direct influence on the development of economics. Okay. Another one is economics really is a dismal science. In that, it lacks a set of immutable basic principles akin to those of physics. Okay. This term, by the way, comes from a man by the name of Thomas Carlyle, who was reflecting on the views of Thomas Malthus about the relation of population and food supply. That's a separate story, which is also very interesting. But it turns out that hypothesis number one, that nobody worth his salt ever worked on economics, is demonstrably false. So here are some of the people who actually contributed to economics. It's a long list, and it's even longer than this. So, and we'll talk about some of these very briefly. The first of Newton. When Newton finished this little project with gravity and mechanics and calculus, he became master of the Royal Mint. Okay. And among other things, he's the one, you see these little grooves on the coins here? That was Newton's idea, because people were shaving off these, the edges of these coins and basically degrading the currency. And so that's where those grooves came from. That's a contribution of Newton. Copernicus, this is really something, because the King of Poland was having trouble with inflation. So you're a king, you're having trouble with inflation, who do you call? Well, of course, your astronomer. So King Sigismund of Poland said, tell me, figure this out. So Copernicus said, it was the money supply. He said that we don't realize that the dearness of everything is because money is cheap. And he said an excessive quantity of money should be avoided. This turns out to be probably the first statement of what is now called the quantity theory of money. Or to all of us in this room who have now been joined in this QTM. Okay, so remember that. This is going to be a consistent theme through the next of the presentation. And here, it started here. Okay. Galileo, he contributed to the theory of value, and in particular what's called the diamond and water paradox. Why do we value diamonds more than water? He talked about scarcity and exchange value, which you can interpret as a very early articulation of the notion of supply and demand. Adam Smith, certainly the most famous academic economist, often called the father of economics, two classic works, The Theory of Moral Sentiments being the first one, by the way, and that's something that's often forgotten. That he was actually a professor of moral science. And his second one, The Wealth of Nations, which is the most famous book on economics ever written, often cited as the most often quoted and least read. And he created by far the most famous metaphor in economics, the invisible hand. And that's the idea that people working toward their self-interest will ultimately act to the good of the group. And we may come back to that. But it turns out his first book, before any of that, was a history of astronomy. Because he was also captivated, as was almost everybody at that time, by Newton. And he said that superior genius of Newton has now made the most admirable improvement that was ever made in philosophy. Philosophy embracing, of course, what we now call natural science. And multiple scholars have suggested that his efforts to discover the natural laws of economics were directly inspired and shaped by the example of Newton's success in discovering the natural laws of motion. In fact, even Karl Marx talked about the laws of motion of the economy. So again, Newton is still with us. He's everywhere. Then we come to Gibbs. And I don't know how many biochemists we have here, or physical chemists, but everybody knows Willard Gibbs. Now, why is that? He created statistical mechanics. He was praised by Einstein as the greatest mind in American history, and this I always find amusing. Anybody here from Connecticut? Look where he published this monumental work, which is often called the Principia of Physical Chemistry, was published in the Transactions of the Connecticut Academy of Arts and Sciences. So seldom read, he had to send this around the world to people. So this is the name of this treatise, and again, it's also often called the Principia of Chemical Thermodynamics. So why mention Gibbs? Why mention Gibbs? Well, because of this guy, Irving Fisher. Now, Gibbs was at Yale, worked at Yale his entire career. In fact, I remember when I was a postdoc there visiting his grave with great reverence. And Fisher received the first PhD in economics granted by Yale in 1891. And he had two faculty advisors. One was William Graham Sumner, who was a sociologist but also studied economics. The other was Willard Gibbs. So here we have the first PhD in this country at Yale, and the advisor was Gibbs. Fisher was maybe the first American celebrity economist. Very well known. Very well known. Often quoted in the newspaper. Had many interests. One of them, like a lot of celebrities, he sometimes sort of had a hiccup. So on October 16th, 1929, he wrote in the New York Times, "Stock prices have reached what looks like a permanently high plateau." And then, 8 days later, on October 24th, the stock market crashed, and Black Thursday began ushering in the Great Depression. So that one didn't work so well. But it turns out that Fisher made many important contributions to economics, some of which we'll discuss. He also lost a fortune, as did John Maynard Keynes, by the way. So that's, again, it's a separate story. Economists and their money. So here again, we have this close interaction. One more example, Paul Samuelson. Some of you may remember Paul Samuelson, very visible economist, advisor to presidents in this country. First American to win the Nobel Prize in economics. Lauded by the Swedish Academy, spoken of as the father of modern economics, and author of a best-selling economics textbook that you can still buy, that's now served, and this is an old quote, so it's probably like 5 million now. Sold a lot of books. So, turns out he's related to Gibbs, because the sole protege of Willard Gibbs at Yale was this guy, Edmund Bidwell Wilson, who was more of a mathematician. He was hired by Harvard, where he mentored Paul Samuelson. So we have this incredible nexus between science and mathematics and economics. So did these close encounters between natural science and economics have any effect? That's the question. Well, until the mid-19th century, political economy was primarily a narrative discipline based on treatises by Smith, John Stuart Mill, and David Ricardo, and others that the economic historians in the audience will know. But beginning in the mid-19th century, let's say, for the sake of argument, about 1850 or so, the influence of Newton and others began to assert itself in the minds of economists, and they became obsessed with the idea of creating a rigorous version of their science, something that could match up with physical science in terms of formalization and mathematization You should try to see if you can say the word mathematization 6 times. I had to practice all afternoon. Mathematization, in particular physics. This became an obsession. And this, I just put this in because I liked it. I don't know if you can read it. It says, Einstein discovers that time is actually money. So, for economists, the last half of the 19th and first half of the 20th century was a time of intense physics and math envy. They were searching for analogs in economics of things like force and work and energy, because these things had been studied by physicists and chemists for a long time and were well understood. And they wanted to use differential calculus to model the influence of supply and demand. So there was an intense interest. This is Irving Fisher's PhD thesis in 1891, or was it 1892? You can buy this on Amazon for $7, hardbound. Okay. So it tells you that this is the difference between value and price. So I thought it was a bargain. Okay. So here's Fisher's thesis, the mathematical investigations in the theory of value and prices. In it he says, in fact, the economist borrows much of his vocabulary from mechanics. Instances are equilibrium, stability, expansion, inflation, flow, and force. So this is a guy who was clearly captivated, and not surprisingly, by the physical sciences, which he had learned from one of the legends of the game, J. Willard Gibbs. His thesis is full of differential equations, full of them. And this is just one example, which if you're having trouble sleeping, I'll give you a copy of this. Ponder. Many of them focused on what they then called marginal utility. And that's a whole discussion of its own, but this would be marginal utility, the change in utility U with respect to the amount of something like apples or something like that. And you look at all this stuff. Okay. Now most of this came to nothing. But it was an important stopping place or place to pass by in the history. A little more about Fisher, particularly for any Yaleys here? Oh, well, that's too bad. Anyway, so Irving Fisher represented his theories by making this hydraulic model of the economy where water represented money. You may feel that your money behaves like water sometimes. And these things would float up and down and represent supply and demand. And he actually used this in teaching economics at Yale for many years. Now there is a rumor that some of the folks from Yale who come here, like Tim Boyer and John Forrest, actually brought this to MDI and installed it in the Yale lab. But we haven't been able to find it. These are some of his analogies. He equated utility with energy, work with disutility. Again, he was mesmerized by the need to try to find some equivalence between physics and economics. Most of this is basically nonsense now, but it's very interesting. And this is an actual picture of this gadget, which is quite interesting. So what became of all this physics and math envy? So by the mid-1960s, attempts to use these mechanical and thermodynamic analogies had been pretty much abandoned. One thing survived, however, and that is this physics-derived metaphor of equilibrium. And it survived in two forms. One is a very highly mathematical, axiomatic approach to the idealized behavior of markets. And these are very sophisticated mathematical proofs. Some of them related to game theory. We were just talking about this earlier. They're very important theoretically and still being studied. In fact, I'm going to talk about them a little bit in my course this fall. But they really have very few implications for economic causality or macroeconomic policy. The other way it survived is in some very important ideological positions. So now we're moving from scientific theory or economic theory to ideology. And here are some of them. Markets are inherently self-regulating. Free markets are supremely efficient and should be left alone and not subject to regulation. Displaced from equilibrium, free markets would spontaneously revert to equilibrium by adjustments in supply and demand. And so the little model that some people use for this is a ball and a bowl, and if you displace the market from equilibrium and give it some time, the ball rolls back down and you're back at equilibrium, which would mean that supply equals demand. In other words, the market will regulate itself. So these are some people you might know. So there's Milton Friedman. Now Milton Friedman spent part of his life as a very legitimate economist. But then he became an evangelist. And once he became an evangelist, all bets were off. And one of the people upon whom he had great influence was the Gipper. So the Gipper, this was basically empty. And so Friedman was around to fill it up with a lot of what we would now call neoliberal economic ideology. And we could talk about the results of that, but that would be even more depressing. So I want to get back to the question of what do economists know? Okay, so I finally got into sort of an answer to this, and I want to make a special point of saying this. This breakthrough for me occurred during a class in water aerobics. And I'm mentioning that because I never thought I would like water aerobics. But it turns out not only did I like it, but I learned a lot in water aerobics. I ran into a guy from Berkeley, and we started talking about it. And like most people, he knew more economics than I did. And he said, well, you should meet Thomas Schilling. Now, Thomas Schilling, who unfortunately is now dead, he shared the Nobel Prize in Economics with Robert Altman for his work analyzing conflict and through the use of game theory. But when I read about him, I knew this is a guy I could trust because he was also consulted by Stanley Kubrick for the making of his film Dr. Strangelove. Okay, so I said, this is a guy I know I can trust. So he made commencement remarks to the Berkeley Department of Economics in 1995 with exactly this title, What Do Economists Know? And so in that, you learn that he had a conversation with a guy named Peter Bauer at Cambridge, who said to him, the number of things that economists know that were true, important, and not obvious was no more than the figures on one hand. And Schelling goes on to say that his candidates, this is Thomas Schelling now, his candidates were all what are called accounting identities. How many are familiar with that term? Yeah, I didn't think so. One. Yeah. So what are they? These are tautological statements that cannot be false. They are true by definition. They're tautological. That means they're true by definition. They can't be falsified. But, and this is the thing that grabbed my attention, according to Schilling, they hold in the same way that the laws of conservation of energy, mass, and momentum. Now, if that's true, then we're really onto something. We're trying to save economic theory, and that would be a lifeline. So, can we investigate that thought? Well, we can. So let's talk about the conservation of energy. So one way to think about it is to think about thermal equilibrium. So we have a hot brick and a cold brick, and we put them together. We all know what happens. The hot brick gets cooler, the cold brick gets warmer, and they eventually come to the same temperature. That's thermal equilibrium. Now I'm required by the laws, by the rules of MDI Biological to recommend that you do not try to do this experiment at home. The lab can have no responsibility. So this is basically the first law of thermodynamics. The total energy is constant. Okay, we go from state 1 to state 2. Okay. And there's a redistribution, a thermal redistribution, but there's no change in the total amount of energy. So total energy, state 1, equal to total energy in state 2. Now, where did that come from? Where did those ideas come from? Well, it was from a number of people. But here's one really important contributor, James Prescott Joule. And those of you who have studied science will remember that a joule is a unit of energy, so he's been memorialized. And so he studied what we call the mechanical equivalent of heat. And that's the conservation of energy from a mechanical process to a thermal process. So is that an accounting identity? Well, here's what he did. He dropped a weight and turned a paddle, measured, he could calculate the energy from this falling weight, thanks to people like Newton and others, and he could measure the temperature change. And it turns out that wherever a mechanical force is expended, and this is a quote, an exact equivalent of heat is always obtained. And this is a footnote. If you read about Joule, people who have actually looked at his measurements are astounded at how accurate they are. Very accurate measurements. So he was saying that the energy is conserved even if we convert from mechanical energy to thermal energy. We still see this exact equivalence. So that's one of several contributions to the notion of the conservation of energy. So is that an accounting identity? Well, turns out, or as we used to say in Michigan, come to find out, Joule's background included, while he was doing this is very funny, he's doing these experiments, he's also running his family's brewery, okay? And what he did there, he kept the books, that was accounting. He also was comparing the work available from steam versus electrical power that was just coming into use, and he was speculating about the interconvertibility of energy. So for him, this was an accounting exercise, I think. Very important point here. Okay. Does the first law imply causality? Now, what do I mean by that? Can we say in this experiment, again, not at home, can we say that A causes B to become warmer? I mean, we know that's the case, right? So you don't have to be bashful about it. That, we know that's the case. But does the first law say anything about that? No. The first law specifies only that the total energy is the same. So in terms of the first law, conservation of energy, this could be state 1, and that could be state 2. In other words, two equilibrated blocks would put together, and one of them got colder and one of them got warmer. And if you do this at home and that happens, call me right away. We know that's not going to happen. So it's a limitation of the first law. There's no implication for causality. For causality, we need to add something else, and that's the second law. And the second law says that state 1 must precede state 2. Okay. Now, that's not important to remember for right now. The important thing is we can have a conservation law, which we know is true, but it says nothing about causality. It doesn't tell us anything about causality. So now we talk about what I'm going to call, and this is open for debate later on, the most famous accounting identity in macroeconomics, and that is Fisher's equation of exchange. So now we're back to Irving Fisher. Okay. And this is it. We're going to go through this in agonizing detail. So MV equals PQ. It looks simple. M in a macroeconomy is the total supply of money. That's everything, all the money. Okay. V is the velocity of money. That simply recognizes the fact that any given dollar may be used more than once. Okay, I give my dollar to you, you go buy a hamburger or a t-shirt or something. so there's lots of turnover. Q is the total quantity of goods and services. P is the average price in dollars per unit of these goods and services. So PQ is what in our economy? The GDP, right? That's everything. That's the GDP. And basically, this is an accounting identity because it says total amount of money times its turnover has got to be what we spent for these P's and Q's. So let's just go through an example. So we have an economy where the sole output is 600 cans of beans, each selling for $30. This economy generates then $18,000 of output. That's the GDP of this economy, $18,000. Now let's say the money supply is $9,000. So it's using $9,000 to purchase $18,000 of output. That means each dollar must change hands twice, so the velocity is 2 per year. That's the turnover rate of the dollars. And if you want to work out the units, I won't belabor this. That's just something you do if you're thinking about physics. Fisher argued that V and Q, the velocity and the total quantity of goods, were in the long run. Now, of course, that's a very pregnant statement, in the long run. We'll talk about what that means. But that they were both constant, he said. So if we solve for P, we get this expression, which says that the price is directly proportional to the amount of money in the economy. And this, turns out, was, and he wasn't the first one to do this by any means, but he's often given credit for it. This is the mathematical statement of what we talked about with Copernicus. If you remember, Copernicus said if you have too much money, prices go up. There's too much money flying around. So this is a mathematical statement of the quantity theory of money. And the causal interpretation is that money causes prices. If you increase the money supply, you get what we call inflation, right? Too much money, you get inflation. So is there any evidence for that? Oh, and this is just the history. Copernicus, I mean, this goes way back. People have worked on this problem for hundreds and hundreds of years. So you don't need to belabor that. Fisher viewed this as an equilibrium, and this is sort of amusing, but his book on monetary theory is full of these diagrams of a balance where this sack is the sack of money, these are the goods, and the lever arms are the price and the velocity. So he loved this idea of equilibrium. And people criticized the equation of exchange for the reason that we mentioned, that it was just a tautology. And so here comes Fisher, and remember Thomas Schilling's quote. Fisher says, truisms should never be neglected. The greatest generalizations of physical science, such as that forces are proportional to mass and acceleration, are truisms. Now, that's a highly questionable statement, frankly. But it gives you an impression of his attitude. Again, this is this descendancy of Newton and Gibbs that is all over him. So, are there experiments in economics? That's something, one of the first things a scientist asks about economics. Well, I think it's fair to say that the best analogy to economics is not physics, but epidemiology. As an epidemiology, you're actually looking back all the time. You're looking at things that have happened, and you're trying to understand why and see if it will tell you something about how you can prevent something like a cholera epidemic, for example, or a measles outbreak, maybe a more contemporary example. And so economics looks back at events like the Great Depression, stagflation, and the 2008 market crash. So here, we do have some epidemiological tests of QTM, M to P causality, and that's hyperinflation. So here's one example. And look, if you look at the time scale here, this is back in the time of Copernicus, and we see all of a sudden, in all of these cities, Spain and England, Antwerp, Amsterdam, there's a there's an inflection point, and the prices start going up, measured in this case in grains of silver. So what do you think happened there? It was a clue. It looks like it's almost about 1492. So Columbus discovers America, and people start mining gold and silver, I think mainly silver in this case, and bringing it back, flooding these countries with new money, and sure enough, the prices go up. So that's one ancient example of QTL. This is a more contemporary one, inflation, hyperinflation in Brazil, where people were printing money with abandon, and you can see here that the consumer price index in red, and the money supply, which is called M1 in this case, you see they change in phase with each other, and even happens twice within the space of less than 10 years. And I put this, again, would be the equation for the quantity theory price, money causing prices. But what happens to velocity? Well, what happens if you're in a hyperinflation environment? The typical example is if the value of your dollar is changing by the hour, and you go in to buy a beer, you buy two, right? Because the next time you order, it's going to cost twice as much. So the velocity or the turnover of money also goes up, and that just exacerbates the whole thing. So this is, in a sense, an example of an epidemiological test for M to P causality. In other words, money causing inflation, as would be predicted by this form of Fisher's equation. The best example, of course, historically is in Germany during the post-World War I years, the Weimar Republic. And here's one of many pictures you can find on the web of German children and others playing with stacks of money because the Deutschmark had become practically worthless. And again, you see this huge, huge increase in the huge devaluation of paper marks in terms of gold marks. So, and hyperinflation has occurred in any number of places: Brazil, Argentina, Zimbabwe is legendary, Argentina. So it's a huge problem. But what about more typical long-term inflation, the kind of stuff we deal with every day? Okay, so here's, this is a plot, and you can find graphs like this. This has been studied, as my dad used to say, until the cows come home. And the correlation between percent inflation, and this is over a 30-year period now. So we're not talking about hyperinflation. We're talking about the total increase in gradual inflation. And if you take long-term numbers, you end up with this correlation that is almost a perfect slope of 1. And this has been done and redone a million times. And it always comes out the same way. I mean, if my data in the lab looked this good, I'd be building it. So what's it mean? So it takes us back to the other question. What about causality? Does this say that M causes P? In other words, that increase in money will always increase prices? Well, we have to pause and ask another question. In other words, is it consistent with this interpretation? Does correlation imply causation? Well, of course, one of the first things you teach students in the laboratory is that the answer to that is no. The correlation does not imply causation. You see it all over the place. And one example of that is a website and a book that I have to credit for. Ed Vance directed my attention to this book, and he never really said this, my thought was he was actually looking for some additional data for a paper he was writing, but that's just my speculation. Anyway, this guy, Tyler Vegan, has just studied data from all over the place and compiled all these correlations, okay? This is just one, and it's very interesting. So this shows that the U.S. spending on science, space, and technology is highly correlated with a coefficient of 99.8% with suicides by hanging, strangulation, and suffocation. So, is that causality? I don't think so. Anyway, this is a very amusing website and book if you want to look at it. So we know from many examples that correlation and causation are not the same. So, and in fact, I have to give Irving Fisher credit. He, in his book on monetary theory, he recognizes this, that this equation of exchange, which is what he called it, does not in and of itself imply causation. There have to be extra principles brought into play. And the one we're making use of now is hyperinflation, where it's pretty obvious that you're pumping a lot of money into the economy because it's the only thing that's left is increase the money supply. Now that brings us back to this, and again the question, is it M causing P? Well, turns out, and this is another thing that's been argued about over and over again, the simple answer is there's no simple answer. Because inflation can be caused by a number of causes. Like let's say a Middle East oil price rise, which would have nothing to do with the amount of money in our economy. And so it turns out, as a matter of fact, that there's speculations that if you get an increase in output, you may increase M causally because people are drawing more money out of banks, things like that. So it's not obvious that the causality goes this way, and in fact people have talked about what they call reverse causality. So the causality, this is starting to sound like the first law. In other words, there's a relationship, a conservation relation, but we can't imply necessarily causality. So are there laws in economics? We would say yes. And there are others, we haven't talked about supply and demand and other very important things. But the causal implications, I would say, are few and often ambiguous. They turn out to have little predictive value, except in this case, in one extreme case, hyperinflation. And as regards public policy, economics remains pretty much an empirical narrative discipline. Now again, you could ask, whose fault is that? Is that the fault of economists? I think not. It's the fault of politicians, who are basing their decisions on economic ideology. And I think the lack of immutable economic principles explains one thing, and that is the centuries of arguments among economists about public policy. In fact, as you might suspect, George Bernard Shaw had something to say about this. If all the economists were laid in the end, they would not reach a conclusion. So I would like to conclude by reiterating what I said in the beginning, that economics is complicated. And I think of economics the way I think about medicine. And that is that we have an economic organism that has lots of pathologies that you can recognize. We have unemployment, we have inflation, we have inequality. So there are few things more important. So the study of economics is important. I think from the standpoint of a scientist, what hampers these things is often the fact that it's hard to latch on to principles that you can use to rigidly define what's going to happen next. Thank you very much.
David, I really enjoyed your talk. And
That's all you need to say.
And here's what I'm thinking, that if you had continued the list of physics forefathers to include Einstein and gone up through quantum theory,
Yeah.
so that the, ending, or at least coming to the point where the universe is made of a bunch of covariant fields, then a couple of things wouldn't be surprising. One would be the lack of truth, because absolute truth can't really exist in that kind of a format. And the probability and statistical descriptions of events would become more important. And the fields would include fields of consciousness, whatever they are, so that the psychology of different people in different situations would drive all
Subjective valuation.
would drive all that kind of inability to conclude one thing.
Well, I mean, I think I'll just say two quick things about that. As regards fields, I think the most important field now in economics is the reality distortion field that seems to surround Washington. And there are many uses of statistics and statistical reasoning. For instance, this fellow that I met in the swimming pool was a guy who worked on making predictions for buying stocks. And he had a very highly mathematized algorithm that they used to make predictions about what would be good bets and not good bets. So there are people doing very sophisticated things like that. Not quantum mechanics yet. That's a ways off.
You mentioned political ideology,
Yeah.
or the politicians have economic ideology. Could you give us some examples of current ideology that affects the economics of our country?
Well, I mean, I think the neoliberal, what people call neoliberal ideology would be a good example. That's the one I mentioned, that free markets are always absolutely perfect. But another one would be, a lot of them are blanket statements. Like politicians say that tax cuts create jobs. Well, you look at the data, it's demonstrably false. Now, if you think about it, a tax cut could create jobs. It may, in some sectors, somewhere from time to time, but on the average, they don't. And particularly massive tax cuts, when you don't monitor what's happening to the money and where it's going. I think that one of the things about, I think a real economist, someone who's really worried about the economy, their reasonings have to be data-driven. Here's a good example. So who just got the latest Medal of Freedom? Yeah. Now there's a laugher for you. Arthur Laffer, famous for the Laffer curve drawn on a napkin. Okay, which unfortunately I don't have a slide of. I have it somewhere else. And he declared, and this is what I call Wall Street Journal economics, because this was all developed in editorials in the Wall Street Journal. And the idea that you would finally see, you couldn't tax, if you taxed enough, I think the curve looks like this, and so I guess it's that the revenue starts to drop off or something. It's all baloney, it was just a hypothetical mind experiment. And I think that's the problem when you look at economics. I guess it's something to, I'm laughing because I'm thinking of something Ed said to me earlier. He said, if they ask you if you're an economist, tell them you're not an economist, but you play one on TV. And that's sort of what you see, is anybody can make an assertion about economics without saying, well, I have all this data, I've collected data for 50 years. And believe me, the data is there. For instance, if you go to it's a bit of a digression, but if you want economic data, you go to these Federal Reserve sites. And you can look up anything you want. A history of inflation, unemployment, it's all there. And so if somebody makes an assertion about A causing B, you can say, well, let's look at it. Let's actually see what happens. Jim?
Missing, I think, from what you've given us is a factor chapter you can't measure, and that's human stupidity.
Or what Keynes would have called animal spirits.
It's always there.
Yeah,
People do dumb things.
yeah,
Can't predict them.
right. Well, that's one of the, the points that's been made by, I'm blocking on his name, the fellow who wrote Thinking Fast and Slow. Tversky and,
Kahneman.
yeah, Kahneman. Yeah, I mean, that's one of the points of that book. That,
Margaret Tuchman's another one.
yeah,
He wrote about it. It's called The March of Folly.
yeah, exactly, yeah. That's about World War I. And, I mean, that's it. We're talking about trying to predict human behavior, which is probably pretty hard to do. Oh, been back.
Yeah, whereas my friend Jim talks about human stupidity, in a capitalistic society, causality may not be an endpoint, because causality has to translate into utility. How can we use this? So maybe we could show causality in Newtonian description of planetary motion. I don't know if you can monetize that. But if someone talks about money and supply and demand, then causality, if there is, and you've sort of taken a position against that, then the causality would lead to some utilitarian usage, which gives a different approach to the economic information and data than it does to the scientific data.
Well, I just would say that this is something that will come up in this course I'm hoping to teach this fall, is that this theory of utility was a big part of the history of economics, trying to understand utility and trying to use utility to predict things like demand. So that's a very important notion. And the idea of where our notions of supply and demand come from and when they apply is also an interesting one. So that takes you into the theory of markets. And the trouble with the theory of markets for a scientist is that you have to make a lot of assumptions if you want to treat it quantitatively. On the other hand, I think we all know about supply and demand. I mean, it's not rocket science, basically. That prices are going to be determined by supply and demand. So I think, and I'm not trying to denigrate that in any way. It's just that it's a little bit different than, let's say, trying to predict where a projectile will land if you shoot it out of a cannon, which we can do almost exactly. Or we can hit the moon. That's fine. Oh, you had a hand up before.
If you could go back for a second to the Fisher comment, I can't see at all that the conservation laws are tautological. I mean, they seem to be fundamentally different, and I wonder who.
Oh, no, I don't, no, I think that's incorrect. In other words,
About Lincoln, he was a well-informed person, and he failed to see a fundamental difference between these tautological statements and a provable law like the conservation master.
well, I mean, that's a good point, and I think you have to remember the times. Again, this is a guy who was, apropos of the time, had learned some economics. He graduated from Yale in 1891, and he was under the influence of this incredible genius of physical chemistry, Willard Gibbs. And I think he sort of picked up, it was almost like something was in the air, because there were a bunch of people who are generally called the marginalists. It was called the marginal revolution. And this is where this trying to quantitate utility comes from, because they talk about marginal utility. If you have something that has utility, let's say you're drinking beer, for example, and you're calculating utility as you drink beer, and that utility for most of us starts to fall off after a while. So the curve looks like this. So that somebody's shaking their head, no, it doesn't fit in like that. So, but the derivative of that curve, the slope of it, is the marginal utility. That's the rate of change of utility. And so that was a big subject. But I think he was simply wrong about that. Somebody had a question.
Dave, a bit off your basic track, but in your work, have you come up with anything about the correlation between income disparity and civil unrest?
Well, I would be guessing, but I think it would be a good guess that people have studied that. Because I think that's one of the things that, you know, if you're looking at theories of value, for example, going all the way back to the early economists, one of the parts of that falls out, you know, you study what things sell for, you calculate what the profits are, and what the wages are. And so this problem with the inequality goes all the way back. I mean, that's what drove Marx, you know, to his theory about what he called surplus utility, that they were, or surplus labor, that workers weren't getting their fair share. So there's a lot written about it historically, but in terms of actual examples, I'm sure there are many that we could find, you know, particularly in some of these third world countries. Maybe sometime in our own, we'll have to see. In the back.
So as a card-carrying academic economist, this talk got me wondering, are there other disciplines where the popular form of it is so different than the academic form of it? Say like in immunology or something like that, is the popular form of that discipline reach so many different conclusions or used so differently than the academic version of it? And I'm sorry, I don't know your background, but so like in your field that you study.
I'm in the witness protection.
Yeah, I mean, do you see such a
I
wide
understand
range
I understand your question, and that's a good one. And I think the answer to it is that that the nature of physics. Let's just use physics as an example. The nature of physics protects us from that kind of popularization, because if I come to you and say, or let's say if you come to me, because you're the economist, you come to me and you say, Dave, I have a perpetual motion machine I want to study. Well, I know immediately that can't be true. I know that can't be true. And I don't even have to look it up. On the other hand, I think you get people like Laffer and later in his life, Milton Friedman, peddling ideas that are either only partially true or true in special cases. And you know, there's this ideological transformation. The way I think of it is you start with legitimate economic theories, and then there's this, it's sort of like making sausage, right? So you progress through various people, and then you get to the people who are actually using them, like Ronald Reagan, for example. I don't want to be too hard on Ronnie, you know, looking back, he wasn't so bad. He knew how to act. And by the time you get there, they know nothing about economic theory, and maybe they don't even care about it. They have some other motive for pursuing that.
Well, as the immunologist that my son-in-law references about vaccination.
Oh, yeah, okay, so there's, yeah. Well, I mean, that's a good point. That's where ideology is taking over something that should be the province of medicine. Yeah, these fears, irrational fears of vaccination, a very good example. Yeah. But if, like I said, if you see me outside selling perpetual motion machines, you can just walk by. In the back there.
Yeah, just three comments. One is I very much enjoyed your talk, so thank you for that.
This is another economist. I'm going to unmask you.
Actually, I'm an economic historian. I feel superior to the average economist. And for good reason. The first thing is, I would say in the post-Second World War period, the profession of economics and economists oversold themselves. Basically, they said, we have the solutions. I made my living, put my kids through college, doing economic modeling, and I would concentrate on the micro area. So one thing I would say is that macro economic modeling is primarily voodoo. Micro, you have a better chance of, you know, understanding the balance between
Right.
supply and demand and coming up with price forecasts. And I was doing
Right.
price forecasts for
Yeah.
forest products industries, for lumber and
Yeah,
plywood.
right.
And if I came within 20% of the actual
Yeah.
price, I was a genius. So, you know, that's one thing. The second, the other point I want to make is about Milton Friedman. He was a charlatan. And basically, the work that he did, and with I think his colleague was Schwartzman,
Yeah, Anna
Yeah.
Schwartz.
was based, you know, on research on, as you said, on the 16th century and the rapid growth of the importation of precious metals from the Americas. And it was bullshit. Because basically, if that theory held true, there should have been rampant inflation after 1600, when the surge of Spanish imports of silver and gold rocketed. And in fact, you had inflation going the exact opposite direction. What Friedman ignored were two major things in the 16th century. One was population growth in Europe, and also harvest cycles. If you want causality and what happened to price structures, you need to look at those things. You
Yeah.
never did it.
Yeah.
And I had, you know, teachers, one was an American, we spent their whole career just collecting information on silver and gold imports from the Americans.
Mhm.
And God bless him.
Yeah,
But, you know, but then you don't see that kind of analysis. You
Right.
don't see the criticism of Friedman, and then he lived on that reputation, as you say, for the next 30 years.
Yeah, well,
Sorry, thank you.
to follow on, I mean, that's absolutely true, and although I'd love to see the papers on that, but I mean, Friedman, for those of you who haven't followed his career, he was a monetarist, okay, and his most famous quote was, inflation is always and everywhere a monetary phenomenon, and that's, again, I think he knew economics. I mean, he studied at the University of Chicago, you know, and he and Anna Schwartz did this, wrote this book, which is now legendary, about the history of money and inflation. But it became transformed into ideology. And that's a very interesting sidelight on this, for those of you who are not yet asleep and want to learn more. I mean, there are great books on what was called the Montpellerin Society. This was a group of people, including Hayek and Friedman and others, who met as a little cabal in Switzerland to rescue the liberal view of economics. And back when they were doing this, which I think was in the 30s, a liberal economist was one who favored free markets. So you have to detach that word liberal from the way we use it today. But that whole history is very interesting, and how they gained control of not only the U.S. government, but also the British government through people like Milton Friedman. Very interesting history.
Thank you so much. Our next Science Cafe will be July 8th, and that will be given by Jane Disney, who is a scientist here at the MDI Biological Lab, and Bruce Stanton, who is a visiting scientist here, but is at Dartmouth as a professor there. So they are going to be talking about, is there arsenic in your well water? And some of you may have heard a presentation that they gave a couple of years ago. We now, a year ago, received a $1.2 million federal grant, and the idea is to engage citizen scientists in this look at wells in the New England area. So they have some interesting data to share with you. Also, some interesting outreach that they've been doing to local schools and engaging children and teachers in that process. And in fact, the reason that we're here in this room today is all of those teachers are here for a workshop on data literacy. So learning how to deal with data and how to interpret that, how to use that in affecting change. So it should be a really interesting cafe. I encourage you all to come. And then July 11th, we have our Family Science Night. So for those of you that are familiar, we turn our campus into sort of an outdoor science fair, if you will, with activities for all ages. You don't have to have children to come. But it'll be a great opportunity. If you do have little ones, it's a really fun evening where our students who are here for the summer and Dr. Bob Morris, who is here in the audience, I see that he is, prepare some activities and games and fun ways to interact with folks to share the work they're doing this summer. So thank you all so much for being here. Thank you again to Dave for a great presentation. Enjoy your evening.